in this second lesson on this chapter, we're going to follow on from what we were doing before. So first of all, here's just a question to remind us of what we were doing in the last lesson about resolving forces. So perhaps pause the video and just have a go at this question. So we've got these three forces acting on this object, which weighs 3 kilograms. And we've got to find the resultant acceleration as a vector and then also as a magnitude and direction. So the first thing to do is split up all these forces into horizontal and vertical components. So we've got this one here, it's going to be 25 sine 40. This one here is going to be 25 cos 40. Let's pick a different colour. This component here is going to be 30 cos 50 from this force here. That's going to the right. And then downwards, we've got a component of 30 sine 50. And then last of all, this force here has got a component to the right of 28 cos 20 and a component upwards of 28 sine 20. So now let's see what's going to happen overall with this object. So if we just look at the horizontal forces to the right, first of all, we've got 25 cos 40 plus 30 cos 50 and then subtract 28 cos 20. And we could calculate what this is to find the net force, but I'm actually going to equate it to ma. So this is F equals ma. The mass of the particle was 3, and then times a. So 25 cos 40 plus 30 cos 50 subtract 28 cos 20. So the net force is 12.12. I'm just going to divide that by 3. So I get A equals 4.04 meters per second squared to the right. If it comes out as a positive number, that must be to the right in the direction that I've modelled it. If it came out negative, that would be overall to the left. Now I've got to do the vertical forces. So I'm going to choose up as my positive direction. So I've got 25 sine 40 minus 30 sine 50 and then plus 28 sine 20. Okay, so just be careful with the sign. So 25 sine 40 is positive because it's upwards. This one is negative because it's downwards. This one here is positive because it's upwards. And again, that equals 3a. So let's find the total force. So total force is 2.66. Now I'm just going to divide that by 3. So A is 0.89 meters per second squared upwards because it came out as a positive number. So as a vector, the acceleration would be 4.04, 0.89. Okay, if I wanted to write it as a vector. If I wanted to actually write it in terms of magnitude and direction, so that's 4.04 across, 0.89 up. So overall, it's moving like that. So you can find the magnitude of A, 4.04 squared plus 0.89 squared, square rooted. So that'd be 4.14. And then the angle, we can use tan. So inverse tan of opposite over adjacent. That's 12.4 degrees above I. Okay. So you can see that there are links to vectors here, and actually I could, if I wanted to, lay this all out as a vector calculation. That's essentially what I'm doing, so I'm just considering the horizontal forces and the vertical forces separately. So I could use vectors to do that. Okay. So all we're going to focus on in this lesson is on something called inclined planes, which basically means slopes. Okay. So here we've got a block of mass 10 kilograms sliding down a smooth slope angled at 15 degrees to the horizontal. Draw a force diagram and show all the forces active in the block. Find the magnitude of the normal reaction and find the acceleration. Okay. So let's just label the information on here first. So this block weighs 10 kilograms. Just put that on. So that means it's got its weight acting vertically downwards, and its weight is going to be 10g. Okay. Its weight always acts vertically downwards. It doesn't matter that the box is at an angle. Its weight always acts vertically downwards towards the Earth. We also know that the slope is angled at 15 degrees. So this angle down here is 15 degrees. Okay. In terms of other forces on it, the reaction force is here. And this is the reaction force of the slope on the object. So this acts perpendicular to the slope. Okay, this one isn't vertical, it's perpendicular to the slope. It's sometimes called the normal reaction force, and that's why, because it's at a normal to your surface. If it was flat on the floor, it would obviously be vertical, but here it's just perpendicular to the slope. Right, so that's part A done. It says it's smooth, so there's no friction or anything like that. Also, if it's smooth, that means that we can probably assume that this is going to slide down the slope. Okay. Find the magnitude of the normal reaction on the slope. Okay. So what we're going to do is we're actually going to split up this weight here into two components, just like we did in the first question. We split into vertical and horizontal. Rather than splitting these forces into vertical and horizontal, when we're dealing with slopes, we split them into parallel to the slope and perpendicular to the slope. So what I'm going to draw is a right angled triangle on here. Okay, so that's 90 degrees in there. Now my reason for doing this is then this component here is perpendicular to the slope, and this component here is parallel to the slope. Okay, and then your weight is the hypotenuse of the triangle. That's quite a useful thing to think about when you're drawing these triangles, is your actual force, so the weight, that always makes the hypotenuse of your triangle. The arrows go in this direction because if the weight is downwards, you can think about how you add vectors together. This component must be downwards and then to the left overall. That would be equivalent to just doing this path here. We could do with knowing some angles in this triangle. If this is 15 here, and again I've got a right angled triangle here, okay, so from here, down here, across, that's a right angled triangle. So that means that if this is 15, this angle up here, that would be 90 minus 15, or you could say 180 subtract 90, and then subtract 15. So this angle up here would be 90 minus 15, which is 75. So then they add up to 180 in this triangle, which would then mean that this angle up here, this is a right angle, because remember it was normal or perpendicular to the slope. So this angle up here is also going to be 15. And this is quite a useful shortcut. If this angle here is 15, this one here is also 15. So you could normally just jump straight to that. Okay. And we're now going to resolve the weight into two components. So this component here is adjacent to the angle. So this is 10g cos 15. And then this one here, this is opposite the angle. So this is 10g sine 15. Okay. Now to find the reaction force, or to find R, we're obviously looking at forces that are in this direction, okay, perpendicular to the slope. So that's what we're going to do. We're going to resolve perpendicular to the slope, which I normally write like that. Okay, so just do an arrow in that direction. So the forces in that direction, to sort of the top left corner, is R. This force is going the other way though. So that's minus 10g cos 15. And I'm using F equals ma here. So that would be 10 times, now the acceleration in this direction is actually 0. It's not lifting off the plane. Okay, so I could have just written r minus 10g cos 15 equals 0, Or you could have even gone straight to R equals 10g cos 15, because this force is balanced with this force. So now I can find R. So that's 10g cos 15. That's me 94.7. Okay. Now to find the acceleration, I'm going to do exactly the same, but I'm going to consider all the forces in this direction, so down the slope, or parallel to the slope. So looking at the forces down the slope, I've got 10g sine 15. That is the component of the weight that's pulling it down the slope. And there isn't any other forces that are in that direction. There's no friction or anything like that. So it's just 10g sine 15 equals ma. So that's 10 times the acceleration down this way. Well, that's a. So now I can solve this to find a. So 10 times 9.8 times sine 15 divided by 10. So that's 2.54 meters per second squared. Okay. Now, using that example, have a go at finding the acceleration and r in each of these cases here. So maybe pause the video and have a go at these three, and then I'm going to go through them. So let's have a look at each of these examples in turn then. So the first thing to do is to draw on your weight and resolve it. So this is 6g, and we're going to split this up. The angle at the top is 25. So this component downwards is 6g cos 25. This component this way, 6g sine 25. And we've also got r. So resolving perpendicular to the slope, I can say that r is equal to 6g cos 25. So that is 53.3. And then resolving down the slope, I've got 6g sine 25. And that equals ma, so that's just going to be 6 times a. So 6 times 9.8 times sine 25 divided by 6. 4.14 meters per second squared. Okay. Next one. Again, put the weight on. Tracks downwards, that's 30g. Resolve it into two components. So I've got perpendicular to the slope, parallel to the slope. The angle at the top is going to be 18. So this is 30g cos 18. This is 30g sine 18. And we've got the normal reaction force up here too. So resolving perpendicular to the slope, I can either write r minus this equals 0, or I can just go straight ahead and say r is equal to 30g cos 18, because it is not accelerating away or into the slope. So that is 30 times 9.8 times cos 18. So that's 279.6. And then resolving down the slope to find the acceleration, because it's going to accelerate downwards like this. And that is 30g sine 18 equals 30a. Then we can find the acceleration. We get 3.03. Okay. Now the last example, I just made it a bit more algebraic, but we should still be able to do it. So put the weight on, which is mg. Resolve the weight, where this angle up here is theta. So we've got mg cos theta, and we've got mg sine theta. And we've also got the normal reaction force. So if I resolve perpendicular to the slope, r is equal to mg cos theta. I can't really do anything else with that, I'll just have to leave it like that. And resolving down the slope, I've got mg sine theta equals ma. And I suppose I could divide both sides by m. So the acceleration down the slope is just g sine theta. There we go. So this is a really, again, this is a really sort of fundamental skill in year 2 mechanics. There's loads of slopes questions, so it's really important that we can do this nice and quickly and efficiently. Okay. Let's have a look at a slightly more complicated example. So here we've got a particle P of mass 2 kilograms. So I'm just going to draw this diagram and then label it as we go. So mass 2 kilograms, so we can put the weight on as well. We can resolve the weight. Is moving on a smooth slope, so there's no friction, and is being acted on by a force of 4 newtons that acts parallel to the slope as shown, so it's pushing it up. Okay, so we've got a force here, pushing the box upwards with force 4 newtons. The slope is inclined at an angle alpha to the horizontal, where tan alpha is 3/4. So they haven't just told us what the angle is, but they told us what tan alpha is. Now if they give you the information like that, so they tell you tan alpha is 3/4, draw yourself out a little triangle like this, right angle triangle, with an angle alpha. So if tan alpha is 3/4, that's opposite over adjacent. So this must be 3, this must be 4. And then you can work out what the last side would be. So here, 3 squared plus 4 squared square rooted is 5. And now using this triangle, we can find sine alpha and cos alpha. And now those are what we can use then in our calculations. So sine alpha is opposite over hypotenuse, so that's 3/5. And cos alpha is adjacent over hypotenuse, so 4/5. And these are what we can use in our calculations. So this is angle alpha here. This is also angle alpha there. This side is going to be 2g cos alpha, or it would be 2g times 4/5. This one here is going to be 2g sine alpha, or 2g times 3/5. Other forces, we're also going to have r here. Okay. Now, we don't actually know if this is moving up or down the slope at the moment. So we should probably try and work that out. To actually determine if it's moving up or down, we just need to compare this force with this force and see which is bigger. So obviously 4 newtons is 4 newtons, but 2g sine alpha, so that's going to be 2 times 9.8 times then sine alpha we know is 3/5. So that's going to be 11.76. Okay, so we can tell that this force is actually much bigger than the 4. So overall, this object is going to accelerate downwards. Okay. Now let's actually calculate that acceleration. We're going to resolve down the slope. So resolving down the slope, I've got 2g sine alpha. Up the slope, I've got 4, so that's minus 4. And the reason it's negative is just because I'm resolving downwards as my positive direction. And that equals ma, so that's 2 times a. And now I can solve this. This is 2g, so sine alpha, I can write 3/5 minus 4 equals 2a. And I can find a. So 2 times 9.8 times 3/5 minus 4 divided by 2. So you get 3.88 meters per second squared. Okay. So all these questions are about resolving them into 2 components and then looking either parallel to the slope or perpendicular to the slope, depending on what you're trying to find out. Okay, here's another question. Again, similar sort of idea. We've got an extra force acting on this one, but this time our extra force is coming in at an angle. So here it says a particle of mass m. So I'm going to draw this out of my diagram. I know I've got one here, but I'm quite fond of just drawing my own diagram to make it clearer. It's pushed up a smooth slope, so there's no friction, by a force of magnitude 5g newtons, acting at an angle of 60 to the slope. Now the way that I'm going to draw this, so I'm going to draw this force coming in, this angle. Let's just make that a bit more precise. And it's coming at an angle 60 to the slope. Now here they've drawn it actually to the slope. I think it's quite useful to draw it like this. Okay, because then that helps us resolve it into two components. One which is perpendicular to the slope. Actually, that should be like that. And one which is parallel to the slope. Okay, because if this force is coming in that direction, the force must be this way and then up the slope. Okay, and it's got magnitude 5g. It also tells us that the particle accelerates up the slope, so this way, with an acceleration of 0.5 meters per second squared. And we've got to show that m is equal to 5g over 1 plus g. So we can do all the usual things here too. We can label on the weight of the particle. So the weight is going to be vertically down, and it's mg. The angle in the diagram, we can see that it's 30 degrees. We can resolve the weight into perpendicular to the slope and parallel to the slope. So the weight is going to go that way and that way. So this is mg, this is 30, so that's going to be mg cos 30. This is going to be mg sine 30. And we could also put r on here as well. Now, this force here, this external force, we can resolve this too. It's coming in at an angle of 60 to the slope. So I can use that to help me draw this right-angled triangle. Again, if it helps when you're drawing this triangle, remember the actual force is going to be the hypotenuse of your triangle. So the 5g is the hypotenuse opposite the right angle. So this force here pushing up the slope is 5g cos 60. And this force pushing into the slope is 5g sine 60. Okay. So we've got all the information on the diagram, and now we can actually go about solving the question. So we've got to try and find m, and we know what the acceleration is, so I'm going to just resolve parallel to the slope and up the slope. Okay, so resolving in that direction. So I've got 5g cos 60, subtract mg sine 30, because that's obviously going in the opposite direction, equals m times a, which is 0.5. And hopefully I can solve this to get this expression here, m equals 5g over 1 plus g, which is what we were asked to show. So let's just do some simplifying. 5 cos 60 is 5 over 2. So that's 5 over 2g. And I'm leaving it all in terms of g, just because my answer's got to be in terms of g. Then this would be minus half mg, because sine 30 is a half. And that equals half m. And I'm just going to multiply it all through by 2. So I've got 5g minus mg equals m. And then we can solve it from there. So 5g is m plus mg. Factor out an m. And then we're basically there. Okay, and obviously you could get this as a number instead, but it did ask us to show that was the answer. If you worked out as a number, 5 times 9.8 over 1 plus 9.8, the mass is 4.54 kilograms, approximately. Okay. Here's another similar problem that I want you to do for practice. So again, probably just pause the video and have a go at this one here. So will it move up or down the slope? So what you've got to work out first of all. And then what would the acceleration be? And also find the value of r, the normal reaction force. So to solve this question, the first thing we've got to do is just resolve all the forces to be either parallel to the slope or perpendicular to the slope, just like we would do normally. So let's put the weight on first of all. So we've got the weight of this particle as 10g. Split that one up. The angle at the top is obviously 30. So this component here is 10g cos 30. And this component here is 10g sine 30. We can also split this force up, the external force. Now, I can see it's pushing into the box here, like that. So that means that this needs to go in that direction and then up in that direction. So this component here is opposite the angle. So this is 12 sine 50. And this component here is 12 cos 50. And then I've also got the reaction force here. Now, the first question is just which way is it going to accelerate? Is it going to go up the slope or is it going to go down the slope? So to work that out, I just need to compare this force here, which is pushing up, with this force here, which is pulling it down. So 12 cos 50 is 7.71. And 10g sine 30, that is 49. So this force here is 49 and that one's 7, so that's much bigger going down. So we know it's going to move down. So we'll accelerate down the slope. Okay. Now we've actually got to find out at what rate will it accelerate down the slope. So looking, just going to get rid of these highlights. So if we look down the slope, just because that's the direction it's accelerating, we now know. So down the slope, I've got 10g sine 30. The only other force in that direction, parallel to the slope, is this one, and that's going the opposite way. So that's going to be negative 12 cos 50, and that equals ma, so 10a. And I can solve that to give me a equals 4.13 meters per second squared down the slope. For the last part, I've got to try and work out r. So to do that, I need to look at all of the forces that are acting perpendicular to the slope. Okay, so in that sort of direction, perpendicular to the slope. So that's going to be this force here. It's also going to be that force there, and it's going to be that force there. Those are the three that are all acting perpendicular to the slope. If I take towards the top left as being positive, then I would have r, and it's going to be minus 12 sine 50, because that goes the opposite way. And it's going to be minus 10g cos 30. And now that equals ma, so it's going to be 10 times, now the acceleration in that direction, assuming this is not lifting off the slope or going into the slope, is 0. Okay, the acceleration down the slope is 4 and a bit, but the acceleration in this direction is 0. You could have written r equals this plus this if you wanted to think about it in terms of balanced forces. And if we solve this, we then get r equals about 94 newtons. Okay, there we are. So you can either get exercise 5b, which is obviously lots of similar questions, or there's also this worksheet. The worksheet is probably a little bit easier, so you might want to do the worksheet first. Okay, and then exercise 5b after that.